this set of videos is about motion graphs. We're going to go through the notes on motion graphs, and the reason why you need to know these is there's basically two ways to analyze motion. We can analyze motion with numbers, and we've done that a little bit already, or we did speed equals distance divided by time. We put those numbers in, we calculate speed, distance, time, and we're going to do a lot of that this year. We're going to calculate and analyze motion using numbers ad nauseum. But we can also do it just by looking at a graph that describes motion. So we need to understand, you need to understand how to analyze, how to understand what a motion graph means. Okay, so in this class, there are only two kinds of motion graphs that we're going to talk about, and you can see them on this page. The first one is called a position versus time graph. And the second one is called a velocity versus time graph. And if you're not aware, you need to know that when we use this designation to talk about a graph, to name a graph, this versus word means that whatever this word is, that's the y variable. The second word is the x variable. So position versus time means position is on the y-axis. Velocity versus time means we have velocity on the y-axis. Before we go on, you should also know that instead of the word position, you might also see the word distance or displacement. I just didn't want that to confuse you. So it's just a different word. So instead of this word position, you might see distance versus time or displacement versus time. It's the same graph. It's the same graph, and all the same stuff applies to it. It just is a different word. And it's possible, instead of velocity, you could see the word speed, but that's not as likely. Usually we will stick with the word velocity. So we showed in class, and I want to understand here, that this little point right here, knowing what the slope of this graph represents for this particular graph is incredibly important, And in order to, I want to kind of prove this to you as we go along. Let's do some reasoning. So let's just talk about slope in general from your math class. So hopefully you remember that just the concept of slope is the steepness of a line. And the steepness of a line can be calculated by measuring the rise over run is what you remember from your graph, from your math class. So rise is just the change in the y value over a certain period of time, and the run is the change in the x value over the same period of time. So for instance, if we're talking about this graph here, if I want to know at this portion of the graph from 0 to 10 seconds, I want to know how much the graph rises, the change in the y value over that time. I want to know how much it runs, quote unquote run, the change in the x value during that time. Now remember, we've also talked about in here, these are just letters, and in math class, it was good enough because they didn't mean anything. We were only talking about the graph itself. But now we got to understand that the graph means something to us here. The graph is describing something that's really going on in the real world. So instead of those letters, we have to understand what they represent. So change in y, instead of y, we should know that our y variable is position. So I could just say this is change in position, and the x variable is time. So instead of change in x, I can say change in time. So this really, to find the slope of this graph, what we're really calculating is change in position divided by change in time. If we were to measure the change in position, the units for that variable are meters. And if we were to measure the change in time, the unit for that variable is seconds. And so we get meters over seconds, and you might recognize that as more appropriately named meters per second, which is the unit for speed or velocity. And that's not an accident. That tells us, that proves to us that when we calculate the slope of this line, the slope of a position versus time graph represents the velocity of that object. That is so incredibly important to know, and I want you to write that up here. The slope is the key to analyzing this graph. Every single question that you will be given about this graph in my class, you can answer by looking at the slope of the line. Every single thing, 100% of the information you need to know will be given by looking at the slope. So the slope represents velocity. That means every single thing you can tell me about the slope is also true about the velocity. That means these words are practically interchangeable. For instance, I could give you this graph, and that's what will happen. Again, so I want you to understand that I could give you numbers regarding time, but it could also just give you a graph. So there may be a problem on a quiz or test where you're just given this graph, and it says, what is the speed of this object between 0 and 10 seconds? Or what is the velocity between 0 and 10 seconds? At first that might sound confusing, but if you understand that since these words are interchangeable, everything you can tell me about the slope is also true about velocity. Literally, you can take the word velocity out and substitute the word slope. So when you read what is the velocity between 0 and 10 seconds, really all we need to know is what is the slope between 0 and 10 seconds. So calculating the slope is something you need to know how to do. That's rise over run. Let's just go ahead and do that really quick. The rise from 0 to 10 seconds is 2 meters. So we'll go change in y over change in x is 2. Change in x. Now be careful about this because a lot of people go 1, 2. Well, it's 2. If you did that, you're counting boxes. We can't count boxes in this class. And the reason, and I know you did that in your math class, we can't do that here. The reason is because the interval is not the same. The interval on the y value is 1. That's okay to count boxes there. But the interval here is 5, so we can't do that. So we've got to make sure and look at what the interval is. So on the y-axis, we start at 0 and we go to 2. That is a change of 2. X-axis, we start at 0, we go to 10. That's a change of 10. So it increases by 10. And then 2 divided by 10 is 0.2 meters per second. So this object is moving at 0.2 meters per second right there during that time period. So everything you can tell me about the slope is also true about the velocity. We calculated the slope of the line. The slope is 0.2, so is the velocity. Specifically, the slope is going to tell us 3 important things about the motion of this object. The first thing you can tell from the slope is the direction of motion. And in this class, the most important way that we indicate direction is with positives and negatives. So the way that we can look at the direction of motion is looking at the slope, looking at whether the slope is positive or negative, right? So positive slope is up and to the right, negative slope down to the right. I think you remember that from your math class. So if we look at this particular graph and number these segments 1, 2, 3, and 4, you might have the same graph and the question could say, during what segment is this object moving to the right or in a positive direction? Right is a positive direction. And the answer would be number 1, because in 1, that's a positive slope. It's not 3, 3 is negative, and it's not 2 or 4. 2 and 4 have no slope at all. If the question says, when is the object moving in a negative direction or to the left, the answer would be 3. So this one is a positive slope, there's your negative slope. So we can look at the direction of motion. We can also find the actual speed, meaning the number. That's the magnitude of the velocity vector. We've already done that. In order to find the speed, all we have to do is calculate the slope of the line. Okay, so we've done that there, and I've told you about that. What's the speed at number 1? If I said calculate the speed at 25 seconds, you would do the same thing. You would calculate the slope of the line during this segment. So we can find the speed of the line. The third thing we can tell about this line, about the motion of this object, is we can tell if the speed is constant or changing. Now again, we're going to determine this based on the slope. Whatever's true about the slope is also true of the speed or velocity. If the speed is constant, the slope is going to be constant, which means you have a straight line. And straight does not mean horizontal. Straight just means simply not curved. If the speed is changing, the slope will be changing, which means the line will be curved. And we don't have any curved lines on this particular graph. So all these speeds are constant. They're not changing. But we will have curved lines on the next page. So if we just look at these 2 questions right here, see if you can answer these 2 questions on your own. Pause the video and see if you can answer them on your own. You might not want to write the answer because I'll give you a specific wording for them. But go ahead and pause the video now and see what you think. Okay, how can we tell if the object is moving? Well, it might help if we kind of think about the opposite question. How can we tell if the object is not moving? Again, everything in this graph is going to be in terms of the slope. So if the object is not moving, what's going to be the slope? Well, if you're not moving, your velocity is 0. Therefore, the slope will be 0, which would be something like this. So it's not moving in 2 or 4. So if the slope is 0 when the object is not moving, what's going to be true about the slope if it is moving? Well, if the object is moving, the slope is going to be anything else other than 0. So as long as the slope is not 0, you have motion. It could be a positive slope, it could be a negative slope, it could be a straight line, curved line, doesn't matter. As long as you don't have a 0 slope horizontal line, there is motion. And now for the second question, how can you tell if the object is going forward or backward? That's direction again, and we've answered that question up above. Again, the answer is going to be in terms of the slope. We know if the object is going in a positive or negative direction because the slope will be positive or negative.